So this is linear rational form part 1. There'll be 2 parts because there are 3 cases to this type of problem. Part 1 here will have case 1 and 2. Part 2 will have case 3. Get right into it. Y prime equals a1x plus b1y over a2x plus b2y. That's the form of the equations for case 1 and 2. Case 1 here is when a1 b2 equals a2 b1. Now if you just work that around, so you get a1 equals b1 over b2 a2, sub it in, do some magic, you get an answer like that. Y prime equals b1 over b2. It's pretty simple. You probably won't get that on a test. So I won't bother doing an example. Just go to case 2 here, which is everything else, essentially. Your first step, you want to substitute y equals bx and y prime equals v plus xv prime. Next thing you want to do is, the goal here is to get rid of that v prime. So you're going to substitute it as dv dx and just kind of work it around, get all the v's on one side, get all the x's on one side, and just integrate those out. Once you've done that, you just want to reduce it and get rid of that v, so you back sub right from here, v equals y over x, and then you're done. So our example here is y prime equals 2y plus x over 2y plus 2x. First thing, we're going to do that substitution. Y equals vx, y prime equals v plus xv prime. You get that equation. And remember, now we want to get rid of this v prime. So we're going to take this v over to the other side here, get it to the common denominator, and add them together. That gives you an equation that looks like that. And we've just factored out the negative 1/2 here. Makes it a little nicer. Next up, a little bit of rearranging. We just got all the x's over here, all the v's over here. We split this v prime into dv dx, so we have 2 integrals here. This integral, a little bit difficult, so we're going to split it into 2. You get v over 2v squared minus 1 plus 1 over 2v squared minus 1. And this integral here, that's very easy. Because we have a natural log here, we're going to write the plus c as a natural log c. It just makes it a little bit cleaner at the end. You don't have to do that, but it's nice. So now we've integrated this one here. Gives you 1/4 natural log 2v squared minus 1. And this one's a little more difficult. I've just left it here. We'll do it down below. And see, here's the combination of these 2 terms here. Natural log of c over the root of x. Just doing the log rules. So we're going to integrate this one here. Now split it by factoring the denominator here. You get root 2v minus 1 times root 2v plus 1. And we're just going to use partial fractions to split those up into something we can integrate a little bit easier. I'm not going to do it all out. You'll get a equals 1/2, b equals negative 1/2. If you're not sure on your partial fractions, check out my other video on that. I'll put a link in the description or on screen. So now that we've simplified that part of the equation, we can just put it back into the original here. So you get one that looks like that. And now we just integrate these 2 out. Those are very simple integrations. I'm sure you can do them. They look like that. And the next step, we're into the reduce and back sub here. You can leave it in this form. You probably won't lose marks. I've just used some log rules here to clean it up. It's arguable whether or not that's better, but I like it better. And now, because we have natural log on both sides here, the insides must be the same, so we can just drop the natural logs and you get that. As well, in this step, I've back converted my v using v equals y over x to get this final equation. It's very ugly. These types of problems will be very ugly, so get used to it, I guess. That's the end of part 1. I'll have a link on screen for part 2.